All right, so far we've talked about physical properties, chemical properties. We discussed last week physical and chemical changes. We're going to talk a little bit more about chemical changes because they're the more detailed of the change. Physical changes just tell us or just change the subject as far as the appearance goes. Like, for example, if I take a piece of paper and I cut it in half, it is still paper. It looks different, but it's still paper. Chemical changes are a little more detailed, a little more complex than that. So we're going to talk a little bit further about these chemical changes. So a couple other things that you need to know. A lot of times when we refer to chemical changes, you might hear them referred to as chemical reactions, because a chemical reaction and a chemical change is the same thing. So chemical reactions are chemical changes. So some of these chemical changes or reactions are permanent, meaning they're irreversible. But that's not the case for everything. So if I burn paper, it's going to turn into ash. I cannot take that ash and form it back into paper. The damage is done. There's no going back. That is a key indicator of a chemical reaction. Now, that is not true for all chemical reactions because some are reversible. But in order to reverse it, I've got to perform another chemical change. So it requires a secondary chemical change or reaction to reverse that process. So an example that I used in class was the example regarding electrolysis. When we have electrolysis, we take water in the liquid form and we run current through it. We're essentially shocking the water, and we're breaking those bonds between the hydrogen and the oxygen. Okay, now this process can be reversed through a process, but it's a chemical reaction that reverses it back. So instead of going from H2O to hydrogen gas and oxygen gas, I can actually reverse that process. So why do these chemical changes create a new substance? Well, when a new substance is formed in a chemical change or reaction, these atoms are rearranging themselves. They rearrange and stick, and the sticking is called a bond. So when the atoms rearrange and stick together, they are bonding together, resulting in a new substance. Okay, so an example that you see down here below, if I have H2 hydrogen gas and oxygen gas atoms, if I bond them together, if there's a process that I can create to bond them together, you would get the hydrogens and the oxygens bonding together. So I'm going from hydrogen and oxygen gas, two separate substances, forming water. I'm creating a bonding and forming a molecule known as water, H2O. Okay, that is a chemical change. So some evidence of chemical changes are other than the fact that we're creating a new substance. If I take a liquid, say a clear liquid, and pour it into another clear liquid and a new color appears, that is a sign of a chemical change. If heat, light, or sound is given off or absorbed, that is an evidence of a chemical change. If I combine two substances and they form bubbles, okay, gas is created. That's a new substance being formed. That's a chemical change. If I combine two liquids together to form a solid, that is a chemical change. And anything else that is irreversible or difficult to reverse is considered a chemical change. Okay, so some other clues to help us with these chemical changes. If a leaf turns from green to yellow, okay, that's a color change. That's a chemical change. If bread is toasted, well, the only part of the bread that is toasted has changed. I can't take that toasted or burnt bread and go back to regular old bread. So the toasted part is a chemical change. Okay. Vinegar bubbles. Bubbles is a sign of gas production. A test tube gets warmer. If it's getting warmer, that means there's a temperature change. Sign of a chemical reaction going on. Two liquids are combined in forming a solid powder. A solid is formed that is known as a precipitate. That is a chemical reaction. Glow stick releases light. Anytime light or heat is given off, that is an energy transfer. That is also a chemical reaction. Okay. On the back side, so matter, all matter, whether it be a solid, liquid, or gas, can be classified and put into categories. Based on its properties. So if we could take a solid, liquid, or gas, we're going to start at the top. Solids, liquids, and gases are called matter. Okay. Yeah, I could break this matter down into two subcategories. I could break it down into pure substances, such as elements and compounds, or I could break it down into a mixture, which includes homogeneous and heterogeneous mixtures, and we're going to talk about each. So let's focus over here on the elements and compounds, pure substances. Okay, so a lot of times as I go through here, I'm going to abbreviate elements as an E, compounds as a C. So an element is one symbol from the periodic table, and it's typically only one uppercase letter. It's usually one uppercase letter by itself, or an uppercase letter and one lowercase letter. These elements are made of one type of atom. Some examples would include hydrogen, capital letter, sodium, one capital letter, one lowercase letter, chlorine, one capital letter, one lowercase letter. Something you might be familiar with, aluminum, capital letter, lowercase letter for aluminum. Okay, these are elements that can be found on the periodic table. Okay, so one symbol. If I have a second symbol, two or more different symbols, I'm forming a compound. Okay, so compounds are two or more uppercase letters. So these are typically written with a chemical formula. And it's made of two or more different atoms. And these two atoms, or two or more different atoms, are stuck together or bonded. So some examples that you can see down here is water, which is hydrogen and oxygen bonded together. You can also see it as salt, table salt, which is sodium and chlorine bonded together. Okay, these form compounds. Now, our second category is mixtures. And there are two types of mixtures. There are those that cannot be distinguished when mixed together, and there are those that can be distinguished when mixed together. Those that cannot be distinguished are called heterogeneous. And those that can be, let's back that up. Those that cannot be are called homogeneous. And those that can be are referred to as heterogeneous. Okay. So homogeneous mixtures typically are uniform in appearance. They look the same throughout. So these are also referred to as solutions. So our example is if I pour salt into water and stir it together, I get salt water. Now, the appearance doesn't change. It still looks like regular old water. Okay? I won't know it's actual salt water until I actually taste it, because I cannot see the salt in the water if it's dissolved properly. Heterogeneous mixtures, you can distinguish the ingredients. I can see the separate ingredients when I mix them together. So they do not have a uniform appearance. It looks different throughout. So an example would be pizza. When I make a pizza, I can see all the ingredients that I put in it, like cheese and pepperoni and pickles. Maybe, I don't know what you're into. What else goes on pizza? Pineapple, mushrooms, okay, dough, sauce. All these things I can see separately when I make a pizza. And towards the bottom here, let's practice. So how many types of pure substances are there? Well, the only two types of pure substances are elements and compounds. Okay, how many different types of mixtures are there? There are two, and I'm going to abbreviate those: HM for homogeneous and HT for heterogeneous. And if you want to add that back towards the top, you can. So we can abbreviate this HT. Oh, did it again. HM and HT. All right, so which substances are variable in composition? All right, so which substances have variable composition, meaning the amounts of the substance can change or be different? Well, that describes a mixture. Okay, which substances have a definite composition, meaning the arrangement of the substances never change. The ingredients are always the same. That would be a pure substance. So, for example, if I've got water, it's always 2 hydrogens for every 1 oxygen. That never changes for water, for a pure substance. Okay. And number 5, are all the following elements or compounds? So we're going to write an E for element or a C for compound. Sodium and chlorine. Sodium chloride. There are 2 elements in there, and I know that because there are 2 capital letters. So these are 2 elements in the periodic table that are bonded together. This is a compound. Ne, neon. That's 1 single element found on the periodic table. C, O2. That's 2 oxygen atoms. Okay, there's only one element, not bonded with anything else, so that's just an element. HCl is 2 elements bonded together. That is a compound. K, potassium, that's 1 element. And water is hydrogen and oxygen. Those two atoms bonded together. That's a compound. And number 6, is the following an element, compound, heterogeneous mixture, or homogeneous mixture? Well, carbon dioxide, it's two elements bonded together. That is a compound. Oil and water, if I mix oil and water together, they will separate. I can see the two ingredients. They will not combine to form one. That is a heterogeneous mixture. A solution, you cannot distinguish the ingredients like salt and water. When I mix those together, I cannot see the salt in the water. It all looks like the same substance. That's homogeneous. And then oxygen gas is just one element bonded together. So that would be E for element.